Lines and coordinate geometry in general is another popular topic on the SAT, so let's review lines right now. Imagine we've got a pair of coordinate axes, and imagine I give you 2 points in this coordinate space. So I give you -3, 0, which is right there, and I give you 4, 4. 4, 4. Now, the segment or the line that connects them is indeed a line. A line is defined, well, if I can draw it straight, a line is defined by 2 points. You can have more points on a line, but 2 is the minimum you need to define what that line is in space. Now, there are a lot of properties of this line. There's things called y-intercepts, which we'll talk about in a second, but the main thing I want to focus on now is the slope. So the slope is a measure of the steepness of the line. If it's positive, it's going to be going from lower left to upper right. If it's negative, it's going to be going in the other direction. Now, how do we figure slope? This is one of the formulas that is not on the test. Now, slope, or not in the beginning of the math section, which is equal to m, is equal to the change in y over the change in x, or, given points, y2 minus y1 over x2 minus x1. So let's find the slope of this guy. We have 2 points. We've got 4, 4, and we've got -3, 0. So we'll call this our point 2, we'll call this our point 1, and make our substitutions. So in this case, y2 is going to be 4, minus y1 is 0, over 4 minus -3. So I'm going to get 4 over 7, and that would be my slope for this particular line. Another way to conceptualize slope is rise over run. It's the more physical, geometric way of seeing it. Remember, slope, which we'll call m, is change in y and change in x. So if I have a slope of 4/7, it's the same thing as saying the following. I can move up 1, 2, 3, 4 units, so it's a rise of 4, and a run of 1, 2, 3, 4, 5, 6, 7 units. And notice these 2 points are now connected with a triangle with a leg here of 4 and a leg here of 7, and it's a right triangle, right? And that is the relationship between slope and triangles and rise over run. So I can then get any whole number fraction of this or multiple, and it would be the same thing. So this is the same slope as, say, 2 over 3.5. So I could rise 2, say from here, 1, 2, and then go run 3.5. So 1, 2, 3.5, right? So again, my picture's a little bit off, but you get the idea, right? So I can create series of similar triangles that are just smaller versions of this, and they're all going to have that same ratio between the sides because that's what the slope is about. So rise over run, you don't necessarily need to know it to do many of the problems, but knowing it can actually help you as a shortcut on certain questions on the SAT. So the slope-intercept formula, that is the famous y equals mx plus b, where m, again, is the slope, which we've talked about, and b is the y-intercept. It's basically where the line hits the y-axis. So in our example over here, our y-intercept looks to be somewhere in the order of 1.5, wherever it would be. We don't have a good example here. But yeah, so that is basically going to be the y-intercept. It's that b form of this slope-intercept form. Let's see. Let's do an example of this. Let's say I've got this line. I've got a line that goes through the origin, and I have the point -4, 3. And I want to know, what is the slope-intercept form of this guy? Well, first I got to find the slope, and you might say, well, I don't have 2 points. But actually you do, and this is a trick that they sometimes throw at you. You do have the origin, which is 0, 0. So we can use that as our second point. So let's figure out the slope. The slope is going to be 3 minus 0 over -4 minus 0, which is -3/4. So we know this is going to be -3/4 x. What about the y-intercept? Well, notice it goes through at the origin, so the y-intercept is 0. So we get plus 0, so we can just leave it as y equals -3/4 x. There are more examples of finding slopes and y-intercepts in the Math Tactics series, so go ahead and check that out. One final thing, this is usually on medium and hard questions, is parallel lines. When you're looking at 2 lines and they're parallel, which means they never intersect, their slopes are equal. They'll have different y-intercepts, but their slopes are the same, right? And that's what makes them never intersect. Whereas perpendicular lines, so let's say this green line, perpendicular to both of them, has the negative reciprocal slope. And again, there are a lot of problems on this in the Math Tactics series. But let's just look at one quick example of what this might look like on the test. Let's say you're given the following equation, 3x plus 2y, can't write straight, 3x plus 2y equals 7. And we want to know, what is a slope of a line parallel to this, And what is a slope of the line perpendicular to this? First thing we got to do is we've got to put it in y equals mx plus b form. So let's get 3x to the other side. So we have 2y equals negative 3x plus 7. Divide it all by 2, and we get y equals negative 3 halves x plus 7 halves. So what would be the slope of a line parallel to this guy? Well, slope of a line parallel to this would be equal to the slope of this line. So it's just going to be negative 3 halves. How about perpendicular? Well, perpendicular is a negative reciprocal of the slope. So we flip this and negate it. So this becomes 2/3. Right? And so you just pick the choice that reflected whatever it was that they were looking at. Right? And that's pretty much what we need to know for lines.